Once our locking of degrees of freedom is over with respect to the application of a load and with respect to the locking of degrees of freedom, now we should again cross check our model. We are missing for one locking of degrees of freedom. In our finite element representative model, we can see over here that we are having a roller supports for these two elements, mass 1 and mass 2. So we need to add for those two again. So come out over here, say solution, define our load, say apply, structural and a displacement. On nodes at these particular two locations we need to apply Uy and Uz. Our Ux is free because we are applying external load in this particular direction, and just say OK. So now we can see we are having a roller supports at these two mass location and all degrees of freedom are locked. After that, once our all inputs are over, now we need to go for the load step options for the frequency range. Just say load step options. In the load step options, we are very well familiar with our given numerical is having a harmonic frequency range from 0 to 7.5 Hz. So we are going for time or a frequency. Let us single click over here. After that, again we need to cross check for a frequency input. So let us single click on a frequency and substeps. Now we are very well familiar with, we need to go for a frequency range of 0 to 7.5 and our number of substep goes 30. So in this ways we need to go for the specification in this particular diagram pop-up window. We can see our harmonic frequency range over here needed is 0 to 7.5, number of substeps 30. Once we are entering for a 30 as a number of substeps, we should say a stepped input. We are going to use a step boundary conditions over here. Because we are needing an answer at an interval of 0.25 Hz, we are entering our 30 substeps. 7.5 divided by 30, the ratio goes 0.25 Hz at an interval we are needing an output. So once we are setting all these things, just say OK. Once we are setting for our time or a frequency range, after that we should say output control. In output control we should say solution printout, it must be on every substep. After that just say OK and again cross check is it on correct place or not. Say results file, it must be on again every substep with respect to the all items and then say OK. After that let us come out of our load step option and solve this numerical. Just say solve the numerical with respect to the current load step and just say OK. Once we are saying OK, we are getting a note as usual, our solution is done. Just close it. After that, instead of following our generalized procedure, so we should go for a general post processor, but we are needing to go for a frequency range and we are going to get for an amplitude and phase angle with respect to the external masses applied having a harmonic loading on a mass 1. So we should say finish first, and after finish we must enter over here, say let us single click over here on a time hist post processor. Instead of going for a general post processor, enter in a time history post processor. We are having a new pop-up window known as time history variables over here. So I need to add the two node locations where I need to calculate for an output. So now we are having this particular window. We can see we are going to plot for a result view for an amplitude. If we are clicking over here, we can go for phase angle also. So first we are going for amplitude with respect to the minimum and maximum frequency range 0.25 to 7.5 along an x-axis orientation over here. Once now we need to add it, say our green mark cross add data. Once we are saying for an add data, we need to add our data with respect to the x-axis displacement because x is free on that particular mass locations where we are applying for a harmonic mass load. Just say OK. Now I need to select for that particular mass location over here and say apply. Once we are saying apply, we are again having the same window back. So variable name must be indicated over here. Firstly we had already entered for ux2 Now it is ux3, say OK. With respect to this particular second mass, and again say OK. Now we are adding over here second and third locations of that particular mass. Now plot the graph. We are getting our graph values plotted according to the third one. Now we can see for the mass location 1, say plot our graph. Over here we can see a graph data. We are getting our graph values according to that one. Now if we need to go for both, so control from your keyboard, select these two parallelly, keep a dot over here in front of your x, in front of your frequency, and after that just say plot a graph. We can see two graphs are plotted over here in a parallel ways. So this is the way we can go for the amplitude calculations. Once we are changing over here from amplitude to the phase angle, and again say plot a graph, we can see a phase angle over here plotted for that particularly. So in this way we can see our list results also. Say list our results. Once we are seeing, we can cross check over here for the ux2 and ux3, means 3ux stands for your mass number 1 and 4ux stands for your mass number 2. In that ways we are going to get our amplitude and a phase angle at a regular interval of 0.25 for the 30 sub-steps. So these are the ways we can go for the calculations with respect to the harmonic analysis using mass and spring element over here.